This video will show you how to use the Poisson distribution formula in Excel from Chapter 5. Recall in our lecture, the example problem used stated that arrivals to a bank ATM are distributed according to a Poisson distribution with a mean equal to 3 per 15 minutes. So here our segment unit is 15 minutes and our lambda is 3 arrivals to the bank ATM. Note that when we're working with the Poisson distribution, we also have to figure out our mean in order to enter into the formula. This is calculated by taking lambda times t, where t is the number of segments that we're dealing with. Now here on the left, we have actually 3 formulas that will let us figure out the probabilities for a variety of scenarios. So we've got the Poisson distribution text that you'll put into your formula, your x, which is your variable of interest, the mean, which you'll calculate using lambda times t, and the third thing you'll enter is either true or false, which will tell you if you're working with cumulative or not cumulative data. Recall in our textbook that our table in the back, in the appendix, is cumulative, meaning the probabilities add up as you increase the x. So let's see here in my notes down below, if you type in the word false, that means it's not cumulative, and you'll use false when you want to find an exact number or an exact x. You'll type in true when you are using cumulative, like we do in our textbook in the appendix, when we're looking for x or fewer. And then if you want to find x or greater, you'll type in a formula where it's 1 minus the formula that uses true. In other words, you're finding the complement of the true cumulative formula, the second one. So let's go ahead and look at our first scenario. So in that ATM problem, we want to know what is the probability that in a given 15-minute segment, no customers will arrive at the ATM. So here we take our lambda of 3, multiply it by our t, which is one segment. We've got one 15-minute segment. And the probability that we're interested in finding is x equals 2. In this case, no customers will arrive at the ATM. So let's go ahead and plug in our formula. Equal Poisson, and Excel will try to pre-populate or guess what they think you want. And in this case, it's correct, so just make sure. Otherwise, you can just type it in. Our x in this case was 0. Our mean was 3. And we do not want it to be cumulative, so we'll type in the word false. Go ahead and hit enter, and that will give us the probability that 0 customers arrived at the ATM in a 15-minute segment. Now, if the problem were different and it asked for exactly 1 customer arriving at the ATM, we would simply plug in 1 for x. If they asked for exactly 3, we would type in 3 for x. Now, let's look at our next scenario. What is the probability that fewer than 4 customers will arrive at the ATM in a 30-minute segment? So there's 2 components to this one. First, we're now working with 2 segments because recall that a single segment is worth 15 minutes. But in this scenario, we're working with 30 minutes. So we know that there are 2 segments involved. So for our lambda t, we're now going to take our lambda of 3, multiply it by our 2 segments, and that gives us a new mean of 6 for our formula. And then to rewrite what our word problem states of fewer than 4 into a probability statement, we use p of x is equal or less than 3. Now you'll also note below in italics, I've also written a few other ways you can say the same thing in a word problem. Fewer than 4 customers can also be stated as less than 4 customers, 3 or less customers, or at most 3 customers. So here you have to apply critical thinking to figure out and interpret what the problem is asking for so that you can rewrite it as a probability statement. In this case, p of x is equal or less than 3. So let's go ahead and plug in our numbers. So again, we've got equal sign Poisson distribution. Our x is 3. Our mean is 6. And we'll type in the word true. And that will give us the probability for when fewer than 4 customers will arrive at the ATM in 30 minutes, or the probability that x is less than or equal to 3. Let's go ahead and do the last scenario. where we want to find the probability that 5 or more customers will arrive at the ATM in a 30-minute segment. So here we're still working with our 2-segment problem now. So our lambda t is still the same, where we take 3 arrivals times 2 segments. So that gives us a lambda t of 6. And then here we're looking for a probability of x is greater or equal to 5. That's what 5 or more means. Now again, in italics below, I've rewritten how the word problem could say the same thing in a variety of different ways. It could have been written as more than 4 customers or at least 5 customers. So hopefully, as you see the different ways the same thing can be said, you'll start to remember to keep an eye out and not make errors in the way you set up your probability statement. Now, when we're working with greater than, you'll note that for P, the probability of x is greater or equal to 5, we actually use 1 minus the probability that x is less than or equal to 4, meaning we're using the cumulative value of just less than 5. So that's where your x is less than or equal to 4. Okay, so for my x, I'm going to use the number 4. So let's go ahead and type in our formula, 1 minus Poisson. Again, I can select it. Our x is 4, our mean is 6, and we are cumulative. And then hit enter. So that's the probability that that 5 or more customers will arrive at the ATM in a 30-minute segment. So if you've got any questions, let me know, but otherwise that's how we calculate the Poisson distribution in Excel.